Hey everybody, this is Larry. This is day 6 of November Leetcode Day Challenge. Hit the like button, subscribe button, join me on Discord. Let me know what you think about today's farm. So today we have a medium. Don't have much to say today. I also rest a lot today. I'm doing active recovery. I'm just going on walks and walking around. Actually, I should go for a walk to pick up dinner. But I actually forgot that there's been daylight saving. I mean, I didn't forget about that per se, but that the daily prompts are 1 hour earlier for me. So I'm going to do this now. But just a little bit of an update. I am going to be in Buenos Aires in like 2 weeks or so. So if you're in Buenos Aires, in Argentina, let's grab food or something. If not, then I don't know. Well, then let's not. Don't really have much to say about that. But yeah, all right, let's take a look at today's problem. We have 3607 power grid maintenance. I really don't like that they've been doing like recent contest problems lately. I only say that because I look at the number, and it's only from like 3 months ago. So like, I don't remember this problem per se, or maybe I will when I looked at it, but I don't remember it by the name in either case. It's only 3 months ago. Like I don't know, like how much is my video going to change even if I don't remember it? Like, so I don't know. But I don't know. I don't know anything. So yeah, let's go. Let's take a look at today's problem, and I am hungry. Let's go. All right. So okay. So you have C power stations. Identify from 1 to C. Okay. 1 based. Okay. You have some bidirectional cables. So you have some connections. Okay. All stations are online initially. Okay. So you're given a list of queries. The 2 type of queries. One is a maintenance request. It resolves if X is okay. So you check if it's online. If it's online, then it resolves the check. I don't know what resolving a check means. If it's offline, the check is resolved with this same power grid. What is the same power grid? Okay, so basically connected components. So basically, so what does this mean? Okay, let me reread this a little bit. So okay, so if X is online, then just return X. Is that what it's saying? And then if X is offline, then in the connected components, the smallest ID. And of course, this graph doesn't change, so we just have to parse it once, and then you just get the smallest ID given that connected component that is online. Okay, and then you could just turn something offline. And there's no turning it online. So what does that mean? Let's see. Right? That means that, okay, so initially, are they all online initially? Okay, yeah, they're all online initially. You could turn things offline, meaning that they're no longer possible as an answer. And yeah, I mean, I think, okay, so this is like the same idea as we had yesterday with sorted list. You can also use a lazy heap, which you can certainly do. But yeah, and because you have connected components, maybe there are a couple of ways you can do it. I mean, I don't think this is too difficult. It's just it's just putting things together. So it's a little bit tricky, both if you just unfamiliar with it. But it's a good practice for harder problems in just like putting multiple things together. Right here, you have to solve basically 2 things. One is to connect the components, which you can do in a couple of ways. And this particular problem is static, right? Meaning that the connected components parts don't change. Meaning that you can do it in, depth first search, breadth first search, union find, because it doesn't change. And then the other thing is just about repeatedly get min, which sounds like a very basically either heap or a sorted list. The reason why heap is a little bit tricky is because you cannot remove stuff from the heap that is not on the top item, right? Easily in the normal normal APIs, normal standard libraries, but otherwise it's the same idea. Yeah. I'm inclined to do it with union find just because it feels easier, but I am going to cheat. Right? No, I mean not cheat, but since this was only like 3 months ago, which is ridiculous, I'm going to see how I did it that problem, and then do it and implement it another way. Right? I think I've already told you how there are ways of doing it, so I don't think this is too much of cheating. I just want to implement a little bit differently. And if you do want to, well, let's take a look, right? So I did do union find that way, so we're doing another way, right? And if you do want to, see how it's done with union find, then just watch that video. It is, you can search for the same thing with my thing, and hopefully it'll be the same idea. Yeah. Okay. So then, let's just let's just go ahead and connect the components. We'll do the same thing that I usually do with right? We create an adjacency list, keeping in mind that this is one based. Oops, that's not right. Connections, right? And this is just adjacency list construction, right? And then once we have that, then now we want to then now we just have to get the connected components part. Sorry, I took a nap and I'm like, I feel good, but also like a little bit sluggish. I have to wake up a little bit. You can say I have to turn on my station. I don't know if that's a good but yeah, okay, so we'll do like a breadth first search, why not, right? So then maybe we have a start, right? And this is just breadth first search stuff. And maybe we have a global a local global thing of, say, I call it parents. Is it a parent? Does it even matter? I don't think it matters actually. So maybe we just, well, no. It just depends on how you want to link it, more explicitly or not. So we'll just call. I reserve the right to modify this, but that's what I'll have for now. Right. Yeah, and then now we write stun of start is equal to true. Something like this, right? But how do I want to represent the list of stuff, right? So basically, what I could do is having like a collections.default dict, right, with a sorted list. And then once I have this maps basically a key value to a sorted list, and then the sorted list will give me all the power grid IDs that are turned on, right? So we can do that, and then that will. So basically, it depends on the key. So basically, maybe like, I don't know, you call it power, right? Yeah, okay, maybe that's fine. And then like maybe we can do it this. No, but then you want to get the root. So maybe here I'll just have a parent, right? So something like this. And then this is going to be standard BFS, right? Right? And then for v in adjacency list of current, right? So if parent of v is not none, if it's not none, then we set it to the current start, and I have to update this. And of course we enqueue the v, and then we should be good, right? For the most part. I mean, yeah. I mean, you also probably need to update it in the power. So maybe we'll do power power of start add start, right? So now I can do power of v dot add v. No, that's not right. Start. Oops. Yeah. And that should be good, I think. I mean, and these are things that if you're not confident about, you can always write tests just for this part, and that's why you want to modularize things in general. I mean, that's not the only reason why, but that's one benefit of modularizing. And one thing about being familiar with TDD, test-driven development, is that it allows you to write code that are easier to test in the future, right? You just get used to it a little bit. But yeah, so then we go from 1 to C, inclusive. we go if, I guess this is actually parent of I minus 1 is none, then we BFS I guess I don't I guess parent. Okay, fine. This is very awkward actually. I don't know. One base stuff always makes me annoyed because like I feel like I don't know. Because it's either maybe they should have done it the other way and did it on the output, like converting on the output. But okay, whatever, right? All right. Yeah, right. And then that should have everything. We can maybe even just print parent real quick so that we see everything is used. So we should see no nones, and of course, maybe I have an infinite loop. Why do I have an infinite loop? Oh, it's not. Oops. Why would that? Silly Larry. All right. Yeah. I mean, we didn't. You know. So this is the entire graph. Okay, that's true. Okay. I mean, these examples are kind of terrible, but I guess that's fine. 1, 2, 3. So there are 3 separate nodes by itself. Is that true? Oh yeah, the node connection. I was looking at the queries and these were the edges, and I was very confused. But yeah, I guess this is fine. All right, and then now we want to say connection or queries, right? So then now for type X in queries, we have an answer thing, right? If T is equal to 1, and you can probably use a switch statement. I don't know. It's only 2 things. So 2 things I divide about whether I should use if or switch. I mean, it's easy to rewrite anyway. But in any case, okay, so if type is equal to 1, then we want to say, okay, so if, I have to keep track on whether it's online. Okay, I thought I could do it implicitly with power, but I guess I actually do need to be, so okay, so, I don't know, on, is that, yeah. I'm trying to think about the naming. Naming is hard. Power on, maybe? I don't know. It goes true, right? Okay, so power on of x minus 1, then we just x, and then we continue, right? Otherwise, if it's not on, then we have to get the power grid, and then we just, it should be, what's it called? So parent of x minus 1, take the power of this, and then the smallest ID, right? So that'll be the 0 item, and that should be good. Else we have to turn something off. So first, well, we turn it off, right? And then we also want to take the power of the parent. So this thing, we want to remove x minus 1. Is it? No, x, I think. Yeah. I think that should be good. Just a quick spin. That shouldn't happen, right? Oh, I guess if, that should happen because that's the -1 case. I forgot about that case. It's a good thing though. If length of this thing is greater than 0, then we do this. Else, and -1, we continue, right? I know the continue is not technically necessary, but it's just, I don't know, in case if we add more stuff later or something, I don't know. Alright, looks okay for the inputs. I mean, these are kind of very basic inputs, right? You have a linked list and then you have a node connection. So I don't know. Am I confident? Not really, but I am lazier. So let's give it a submit. Oh no, one not in list. Do I insert the wrong thing? Oh, because you could keep on powering things off. Alright, I hate you. Okay, so yeah, okay. If power on x minus 1, okay. I wonder if I did the same thing last time. I don't know. Maybe I did rush it a little bit though. That was the second example. Okay. Yeah. So that's basically the core idea. I am gonna. I did the same thing last time. I did the same thing last time. I guess things didn't change that much in 4 months, and you can't even say that I remembered it because I clearly did not. Okay, I guess union finds a little bit faster, at least in the way I implemented. But yeah, what's the complexity, right? Well, BFS is just going to be linear, right? But it's not linear in the size of necessarily C. It is actually linear in the size of the connection. So we're actually pretty good with respect to that. But because of this thing, it's actually technically C plus. Well, C is actually not the number of connections, right? C is the number of nodes, right? So maybe this is even like a V more than V plus E. So this is like V plus E, which is not technically linear, but yeah, that's for the BFS part. And then for each query, we do O of one. Oh, wait, actually, I lied. Wait a second, I lied. I forgot that I used sorted list somewhere. So I did lie. Well, I mean, it just means that because for each for each node, for each vertex, we do a log n or log v operation. So it's gonna be v log v in total, right? Because this thing only gets added at most once per node. It's gonna be like v log v plus e, right? That kind of linear, because you still have to look at each edge once. And only once, right? Or maybe twice if you want to count it backwards, but O of E, right? Yeah. And and yeah, for queries, yeah, so this is relog, and yeah, for this one, you can, I mean, you know, it's either you I always forget whether get min is O of 1 or O of log n in sorted list. But either way, it doesn't, you know, because this remove is log n as well. So I don't know. So I guess in the worst case, you can do a log n thing, q log n or q log v or whatever. And that's it. That's what I have for this one. Let me know what you think. Let me take a look at what I did last time more fully. I mean, I just saw the U find. I was like, I knew this is union find, so I kind of stopped. But I mean, I guess this is pretty much the same idea, really. Oh, and the difference is I used this card. Oh, if I used remove, got the exception, and I used this card. I mean, same thing, but yeah. Anyway, that is all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.